Okay, so we discussed like what an independent and dependent variable were. Okay, and then we also kind of discussed that like an equation is kind of like a machine, right? So we can input things into the machine, and from that we get output. So in this case, the inputs are these t values, right? Which we highlighted as being all these here, right? And then we got outputs when we inputted the t values into the t. So we're gonna like fill out this table and we're gonna get values for d based on the t values that we plug in, right? So a little aside work, what we'll do here is we'll plug in the first value of 0, right, into t. 0 squared is 0 times 5. It's just going to be 0, right? So the first value is going to be 0. That maybe might not have been the best one to select. So let's go the next one here. It'll be 5 times 1 squared. And you always have to do the 1 squared piece first, right? So it's 5 times 1, right? Which is 5. Okay? You're just going to keep going through there, right? It's like a machine. Input things and get outputs, right? So then the next one's going to go 5 times 2 squared. So it's 5 times 20. Sorry, getting ahead of myself. 5 times 4, right? So it's 20. And it's 5 times 3. 5 times 9 will be the next one, right? Which is 45, right? And then the last one will be 5 times 16, which will be equal to 80. Okay? So then you just got to go plot those points, right? And I think you got to create like kind of a corresponding axis. So we can kind of go there's 0, 1, 2, 3, 4. That fits kind of all right. And then we're going to have to go up by, I guess, tens maybe. 10, 20, yeah, we can go up by tens. 10, 20, 30, 40, 50, 60, 70, 80, right? Are we okay? And you just plot the points, right? So like this is an instance of like a function producing a graph, right, from a table of values. So I input things, I get outputs, and then I can plot. The graph is just a graph of things that I've inputted and their products on the other end, right? That's all it is. So x and y, right? Or in this case, t and d. So it started at 0, 0, and then I'm going to go 1, 5, and then I'm going to go 220, and then 345, and 480. Right, so there you go. Right, that's it. Is that a function from yesterday? Remember we talked about functions yesterday, right? So if, we had a particular test that we would use, right? That's called the vertical line test. And if I kind of dissect this graph any number of times, I can put them in between, right? The point is, at any given time, these vertical lines only touch the graph once. So then it is a function. Okay, that's the vertical line test. Nothing fancy about it, just that's it. Okay, make sense? So it would be a function. Okay, so then the bottom part here is just we can produce these graphs and then see if they're functions or not. Okay, so I think the assumption with the first one is that you guys are kind of okay with that. That's just a line, right? This is y equals mx plus b, like grade 9, right? So then all you got to do is go, okay, well, where's the y-intercept? It's right here, right? That'll be your b value. So that's where it's going to cross the y-axis, right? So it crosses at positive 3. So I'm going to go 1, 2, 3. So it crosses there, and then it's the slope. The slope is kind of the number in front of x, right? So that's saying the same thing as 2 over 1, right? And then we remember that slope is equal to rise over run. right? Which basically means I'm going to go up 2, right 1, there's a point. Up 2, right 1, there's a point, okay? And then the opposite of going up 1, right 1 would be going down 2, left 1. Down 2, too far, left 1. Okay? And then I can create my line. Okay? And you guys can come up with your own kind of generalizations that you just know that a line is a function, right? Unless there's one instance of that not being true, which I'll show you in a sec. But like you can see, if it doesn't matter, if I do my vertical line test, it's only crossing that graph once for any particular, like any x value that I pick, a vertical line, it's not gonna, it's just touching that graph once, right? So then it is a function. Okay. So there's your graph. Okay. Okay. Now, can anybody think of one instance where there might be a line that is not a function? Kind of
any line that wouldn't be a function.
Wouldn't be a function.
I don't know how to get like the formula that would create it, but if you had like a parabola that was for some reason going like that instead, I don't know how to.
Okay. What about like? Yeah.
Like a line that goes through the y-axis.
Okay. Through the y-axis, so only the y-axis, right? Is that what you're saying? What kind of line is that? Vertical line. So like if I had a vertical line on this graph, right? When I went to go do my vertical line test, I get multiple points along here in which the vertical line crosses that function. That's the only instance in which a line is not a function if it's vertical, right? Because it fails the vertical line test. Did everybody see that? Okay. So that's a lot of talking, but this here you can say this is a function. And you can come to the conclusion every time you see an equation that looks like this, right, where it's y equals mx plus b, that's a function. Okay, the lines are functions unless they're vertical. Do we know what the equation for a vertical line looks like? So vertical lines, if I looked here, this would be 1, 2, 3, 4, 5, 6, 7. So it would have an x value of 7, right? Everywhere along this line, doesn't matter what y value I pick, what's the x value? How far back did I go to the left? 7, negative 7. So like every y value along this line has a value of x of negative 7. So the equation is going to look like this. That's a vertical line. That does not pass the vertical line test. It's not a function. Okay? Okay, are we good? This one, you can we could do what we were doing before. We'll just plug in, we'll have inputs. Typically with parabolas, I like plugging in like -2 through whatever, but in this case, we'll just go negative. I'll just write this down. You guys can, it's the same thing we did earlier. No problem. I stole it, yeah.
Are you using it?
It's up there. I can get you it later.
I can't
Do you need
connect
it
anything.
You can't connect
I
anything?
can't get my computer.
Does Mark have one?
To connect, I don't know. I hate it when I get used to that. I get in the classroom and everything working for me.
Yeah.
For me, and now nothing works.
I spent all day Sunday sorting that out. It was a pain.
Okay.
Okay. -1, 0, 1. Okay. I'm just gonna do this quick. So this is like again same thing we did earlier that I showed you here, right? See, like we inputted things and we got outputs. You can sit there and do that. Okay. For the interest of time. Okay. I'm not going to do that. I'm going to do, I'll write the first one for you first, right? And then I'm not going to do it, okay? So it's 2 times negative 3 squared plus 5 times negative 3 plus negative 3, okay? That's going to equal, or it should equal, and you guys can check this for sure, 6. Okay. And the rest of these, I'm just going to do the same thing for the rest of these, but they're going to come out to be 1, 0, 3, and 10. Okay. So then you could take those points. I have inputs and outputs, like I did before. There's my inputs, right? And I have a whole bunch of outputs, right? These values. And I'm going to plot them on the graph. And I'm going to see what shape does it give me, right? You will find it, right? Negative 3 and 6. Let's go negative 1, 2, 3, and then negative 6. 1, 2, 3, 4, 5, 6. So we're right here. Right here. Okay, there's 1 point. That's the first one. Taken care of. Negative 2, 1. That's right here. Right? Taken care of. Negative 1, 0. That might not be right. What's going on? Did I go the wrong direction? I went the wrong direction. You guys didn't say anything, see? Problematic. So what's going on? Negative 3, positive 6. 1, 2, 3, 4, 5, 6. There we go. That looks better. Okay? And then 0, 3. 3. And 1, 10, which will be off the graph. Right? So we're going to get something that looks like this. Okay? Is that a function? Yeah, right? Because if I do my vertical line test, it's only going to pass those points once, right? So you can come up with a generalization that, like, how did I know that this equation, or this function machine, we'll call it, gave me this graph? Right? How do I know every time, like the same way that I see this, this gives me a line, right? How do I know that this gives me this shape every single time? It's the x squared. It's a parabola. Okay? Parabolas will give you a function every time, right? Just another one of your generalizations. Okay. Does that make sense?
What would the basic formula for that be? Y equals mx squared.
Oh, okay. So yeah. So here's your line. So a line's going to be y equals mx plus b. That's always going to look like that. And then a quadratic, that's going to look like y equals x squared. That's your base graph. That'll go through like 0, 0, 1, 1, negative 1, 2, 4, 4, 4. That's your base graph. Y equals x squared. Okay. And then if you took grade 10 academic, you would have done transformations of that, right? So you reflected it or moved it around. Like, we'll do more of that in this course. That's what's kind of nice about the M, is it's kind of a nice bridge between, I think the expectation is kind of like we pick off where the two P's leave off, and then we build you to kind of like, you're going to go take the 3U. That's what's great about this course, right? You get a really good base again, and then we pick you up and throw you to like towards the 3U. That's kind of the goal, right? So those are your two rules so far. And I think we're going to do a few more functions in the course. Like, those should be the only two that I think you really know, right? And if you took the 2D, you may know this one. Do we know what this is? What shape that produces? So anything, so this looks a lot like, well, this equation comes from triangles and Pythagorean, right? But this takes on the notion that x squared plus y squared equals r squared.
Yeah.
R being your radius. What do you associate radius with?
Circle.
Circles. Okay. So like this one here you'd have to write this equation like this. X squared plus y squared is equal to 3 squared.
3 squared being
3 being the radius, right? Okay, so you could go find, I know that the circle has to follow points like this. Okay, it has to have a radius of 3, right? So that means from the origin to its outer edge, it has to go 3 units, right? So I can go, I like to use the axes as my points of reference because anything in between the axes gets a bit awkward, right? So I don't need to do that, but I can go out to 3 here. I know that's 3 units for sure, right? And then I also know that this is also going to be 3 units. 1, 2, 3. And I know there's 3 units to the left. 1, 2, 3. And I know that there's 3 units down. 1, 2, 3. Right? I know it has to be 3 units along all of the axes. So now I can create my circle, right? Oh, it didn't do it. Yeah, boom. Here you go. Okay, here's your circle. That's what that looks like, right? Is that a function? We talked about that yesterday, right? So if I do the vertical line test on here, I cross at 2 points. Fails. Not a function.
So
Yeah.
I could say that's just a relation, right?
Yeah, it's a relation. Yeah.
Or
It's
let's say not.
a good question. I have to think about that. I would think like, so when I work at Golf Town, and at Golf Town, like when we'll do like a cluster, like people hit balls into the sim, right? And then all the balls, you get a dispersion out in the range, right? But on the left-hand side, they'll put like a circle down like this, representing a dispersion of your shots. So I would think they're related in some sense. Like I'm trying to make the connection vocabulary, like that there's a relation amongst what's happened. It's with a circle, but it's definitely not a function, right? Because the function is very strict in its definition. But there obviously has to be a relation between data points in order for there to be. I think that's kind of what it's getting at. That would be my assumption, right? But I can check that. Okay, so that's it. Do we have any questions? That finishes off yesterday's. And